Hello everyone and welcome back to the screencast series of Quick Start Guide for Asset Administration Shell. Since last few videos, we have been working on the first part of this series, that is nothing but the data provider's perspective. In last few videos, we have seen a few steps for this perspective, that is nothing but how to choose an asset, how to choose a use case, how to model an asset administration shell for this asset, for example, a car, how to validate this shell and the submodel against the specification of the IDTA. In the last video, we have also seen how to deploy this model asset administration shell in an server of asset administration shell. And now in this video, we are going to see how to register this asset administration shell and the submodel into a registry. But what exactly is this registry? So a registry is nothing but a directory in which the identifiers of this shell or submodels are stored together with the corresponding endpoints. So nothing in the registry you can find the locations for these shells and the submodels. So in simpler words, just like a telephone directory in our day-to-day life. Now, for this example, we are going to use the AASX server again as for registry. Now, in the last video, we have already seen the AASX server as a deployment option for the shells. We have already deployed the My Car Asset Administration shell in this AASX server. And now in this video, we are going to use the AASX server, the another instance of AASX server for registry. Now for this, I have already downloaded the latest version of the AASX server and installed it. Now, where to find the server, how to install it, and how to start it. So if you are interested in all these detailed information, then do visit our previous video where you can find all this information. Now, after installation or after extracting the ASIC server, the Blazor version, where you can have the visualization part, I can see the folder structure somewhat like this. Now, as we know, there is one folder where the shells to be loaded are stored. So here I have already loaded or already stored one ASX file that is nothing but the registry file. So this file will already be provided in the description box or in the location. Now, this file is very simple. It consists of an asset administration shell and the two submodels, one for the AAS registry and one for the submodel registry. Now, these two submodels, they just act as a storage to for the AAS for the registered shells and for the registered submodels. That's it. And we will see how this everything is put together in some time. Now, as this shell is already placed in the path, now let's go back one step further and let's try to start the server. Now, before starting this registry, as we have already one instance of the AASX server running, we need to start this registry with another port. For this, I have already changed the app settings.json here. The port number I have changed from 5001 to 5002. And in start for demo.shell script file here, I have also changed in the external Blazor parameter. I have changed this port number from 5001 to 5002 again. Now we are all set to start the registry. Let's double click on this, which starts the registry. As we can see, there is no security enabled, and we can see that one asset administration shell has been loaded successfully. Now let's go back to the browser and let's start the server, or let's open the server in the browser. As we can see, the shell has been loaded successfully with empty submodels for the registry and the AAS registry and submodel registry. So far, the server or the registry has been started. Now the question is, how do we register this shell into this registry? For this, we are going to use the APIs provided by the IDTA specifications for this registry. Now, I'm going to use the Swagger documentation or the Swagger APIs supported by this AASX server. So the Swagger documentation Swagger documentation of the AASX server can be found at the swagger/index.html link here. And here, as we can see, there are multiple APIs or multiple operations. We are interested in this registry API related operations. And here, as we are going to create a new shell or registry, we are going to use this particular operation that is nothing but the shell descriptor. Now, the payload that we use to create to register the shell into a registry is called the descriptor. So when we are going to register a shell into the asset administration shell registry, it is a shell descriptor. When we are registering a submodel into a submodel registry, it is a submodel descriptor, and so on. So for this, there is a structure, the payload, as we discussed, and the payload looks somewhat like this. So it consists of the asset kind. In our example, my car asset administration shell, it is instance. Then it consists of endpoints. As we said, it is a registry, it is a directory of endpoints of the shell or the submodels. Uh, then here, in the endpoints, it consists of the endpoint of the shell, where exactly I can find the shell. As here, there is the server endpoint uh, with the appended slash shells, and then the base64 URL encoded AAS identifier. So this is how we read this whole the endpoint for the asset administration shell. In addition to that, there is this global asset identifier for my car AAS, then the ID short of the asset administration shell, the identifier for the asset administration shell. So this was the information about the asset administration shell so far. Then comes the submodel descriptor to register the submodel at the same time. In this case, we have again the endpoint related to the submodel. So as we have seen here in our example, my car asset administration shell, we want to register this submodel as well. For this, the endpoint of this submodel. So again, the endpoint of the server, then the endpoint of the submodel as well. So here there is this base64 URL encoded submodel as well, the identifier of the submodel, the ID short of the submodel, that is nothing but the digital nameplate, the ID, and the semantic ID. So this is how the whole payload of the descriptor looks like. The more information you can also find into the specification of IDTA, where there are some additional optional parameters as well. Now I'm going to copy this AAS descriptor and I'm going to go into the Swagger UI, click on this try it out, and I'm going to paste it here into the body of the request and just click on execute. If I check here, the request was successful as the result code or the status code is 2001. And if I go back to the registry, I can see that in the AAS registry, I can see there is one shell descriptor, and in the submodel registry, there is one submodel descriptor as expected. Now in the shell descriptor, I can see that there is my car AAS, there is AAS identifier, asset identifier, then there is endpoint. So this is nothing but the location of the shell. So if I copy this and paste it, this is nothing but the JSON serialization of the shell. So this is the location of my shell. So this is the whole shell descriptor. Now, if I come back to the submodel registry or the submodel descriptor, then I have ID short, submodel identifier, semantic identifier, and again I have endpoint. So nothing but the location where I can find the submodel. Again, if I try to locate this, I can see I can access this particular digital nameplate. We are going to see this whole mechanism of accessing this information in the consumer series again. So this is how we basically register the asset administration shell and submodel into the registry. Yes, so as in this video, we have seen the registry part from the data provider's perspective. So this was the end, or this was all the steps, all the necessary steps from the data provider's perspective um, for starting with the asset administration shell. Now, in the next part of the video, that is nothing but the data consumer's perspective, we are going to see that how to start with accessing or consuming this data as a consumer. So if you are interested in the consumer part of the series or the screencast, then please stay tuned with the series. Thank you.